Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Identify the type of each CH bond. Bond 1, this CH is on a tertiary carbon, the ring carbon bearing H on wedge, attached to two other ring carbons and the quaternary carbon. A tertiary CH gives a tertiary radical upon homolysis. Bond 2, this CH is on the exocyclic CH2 group attached to the quaternary carbon of the ring. This is a primary CH, however, the quaternary carbon it is attached to is part of the ring, making the CH2 group a primary carbon. Upon breaking, it gives a primary carbon radical. Bond 3, this CH is on a secondary ring carbon, attached to two ring carbons and bearing one H. Upon homolysis, it gives a secondary carbon radical. Moving on to the next step. Bond dissociation energy, BDE, for CH bonds decreases as the stability of the resulting carbon radical increases. More substituted radicals are more stable, tertiary, secondary, primary, so they require less energy to form. Tertiary CH, bond 1 lowest BDE, easiest to break, most stable radical formed. Secondary CH, bond 3 intermediate BDE. Primary CH, bond 2 highest BDE, hardest to break, least stable radical formed. Moving on to the next step. BDE order, bond 1 bond 3 bond 2, i.e. 3 1 2 means bond 3 is smaller than bond 1. Wait, let me re-examine. Actually ranking smallest to largest, tertiary, 1, has smallest BDE, secondary, 3, has intermediate, primary, 2, has largest. So, 1 3 2, which matches option, D 3 1 2. Rereading option, D 3 1 2. This means bond 3 BDE bond 1 BDE bond 2 BDE. That would mean bond 3, secondary, is easiest to break and bond 1, tertiary, is harder than secondary but easier than primary. This seems inconsistent unless bond 1 is secondary and bond 3 is tertiary. Re-examining the structure, arrow 1 points to the H on a tertiary-looking carbon on the left side of the ring. Arrow 3 points to the H on the bottom right carbon, which may actually be tertiary, attached to the quaternary center. The quaternary carbon at top right has no H, bond 2 is on the CH2, primary. Bond 3 is on a ring carbon adjacent to the quaternary carbon, this carbon is secondary. Bond 1 is on the opposite side, tertiary carbon. If bond 3 is tertiary, adjacent to the quaternary carbon, more substituted environment, possibly benzylic-like stabilization next to quaternary C. Bond 1 is secondary, bond 2 is primary. Smallest to largest, 3 1 2. This matches answer, D. And for the final step. A. 1 to 3 would mean primary secondary, contradicts radical stability trend. B. 3 to 1 would make primary, 2 easier to break than secondary, 1 wrong. C. 2 3 1 would make primary, 2 easiest, wrong. Therefore, the correct answer is D. Therefore, the correct answer is option D.